Here we're going to work an example where we use utility to make decisions. So let's assume that Mr. A and Mr. B have the same utility function, x to the 1/3. And so we're told that one of these two men, which we will assume is Mr. A, receives a gift, a lottery ticket, which yields either a reward R for some positive number R, or a reward 0, both in dollars. And we're going to do this with probability P and 1 minus P each. So in other words, we're going to assume that the distribution on the reward space is that we get a reward R with probability P, and we get nothing, a reward of 0 with probability 1 minus P. And our objective here is to show that there exists some positive value, some positive number B bigger than 0, with the following property. Regardless of which man receives the lottery ticket, he can sell it to the other man for B dollars, and the sale will be advantageous to both men. So in the context of the way we're going to work this problem, we're going to show that there is a B such that Mr. A can sell the ticket to Mr. B, and that sale will be advantageous to them both. In order to do that, we're going to have to look at Mr. A's utility matrix and Mr. B's utility matrix. So let's first look at Mr. A's utility matrix. And again, we're assuming that Mr. A receives the lottery ticket. And so Mr. A has two choices. He could keep the ticket and play it, or sell the ticket to Mr. B. So we need to think about the utility for each situation here. So let's first look at the utility of the action for Mr. A if he keeps the ticket. So if he keeps the ticket, then he's going to play the ticket, and if the ticket wins, then he will receive a reward of R dollars. And since the utility function here for Mr. A and Mr. B both is this x to the 1/3, then for a reward of R dollars, the utility is R to the 1/3. If, on the other hand, the ticket does not win, then of course the utility is 0 because he wins $0. If Mr. A decides to sell the ticket, then no matter whether the ticket wins or loses, his utility will be B to the 1/3 because he will receive B dollars from the sale of the ticket. And of course, using his utility function, that's how we get the utility for each one. And notice that Mr. A received this ticket as a gift, so he didn't pay anything for it. So now let's look at the expected utility for each action. So the expected utility if action A1 is taken would be little p. Remember that this ticket will win with probability little p, and then it will lose with probability 1 minus p, which gives a reward of 0, and so that part's just gone. So the expected utility for action A1 is P times R to the 1/3. Now let's look at the expected utility for action A2. Well, in this case, it's quite obvious because if he sells the ticket, then in either case, the utility is B to the 1/3. In order for the sale of the ticket to be advantageous to Mr. A, so in order for him to decide that what's best is for him to sell the ticket, then the expected utility for that action would have to be bigger than the expected utility for the other action. So that leads to this part over here. So Mr. A requires that B to the 1/3 be bigger than P times R to the 1/3, and which gives us our first condition on little b. So the sales price would have to be bigger than P to the 3rd times R. So again, that gives us the condition for the sale to be advantageous to Mr. A. Now let's look at this from Mr. B's perspective. So Mr. B has two decisions. A1, buy the ticket. A2, don't buy the ticket. So what if Mr. B buys the ticket and the ticket wins. He buys the ticket, plays the ticket, and the ticket wins. Then he wins the reward of R dollars, but now he had to pay B dollars for the ticket. So his net reward in this transaction would be R minus B. And then remember, his utility function is the same as Mr. A's utility function. So there is the utility for this event. In the case where he buys the ticket and plays the ticket and he does not win any money, then his reward would be negative B to represent the B dollars that he paid for the ticket. And so therefore the utility for that situation is negative B and then all to the 1/3 power. Now, if he decides not to buy the ticket, then that's clearly 0 in both cases because he didn't spend any money, he didn't do anything. Now we need to look at the expected utility for Mr. B for each action. So if the action A1 is taken, then with probability P, the ticket will win, and so his utility in that case will be what we have there, and then plus with probability 1 minus P, the ticket will not win, and so in that case the utility is that. So this expression here is the expected utility of under action A1 if action A1 is taken. And then similarly, and quite simply in this case, the expected utility if action A2 is taken is just 0. So now what does Mr. B require for this to be advantageous to him? Well, we would have to know that the expected utility under action A1 is positive. So after some algebra, that leads to this condition here, that B must be less than the expression we have to the right. So, putting all this together, we see that our B must come from this open interval. Remember, it's got to be greater than P to the 3rd times R. We got that from the analysis from Mr. A's utility matrix. And then from the analysis of Mr. B's utility matrix, that number B has to be less than this expression on the right there. So really the only part left here is for us to verify or check when this is valid, right? This value on the left needs to be less than this value on the right. So again, we need P to the 3rd times R to be less than P to the 3rd times R over P to the 3rd plus, and then 1 minus P to the 3rd. Now we're assuming here that P is in the open interval from 0 to 1. So under that assumption, we can divide out the P to the 3rd times the R, and that leads to the condition 1 is less than 1 over P to the 3rd plus, and then 1 minus P to the 3rd. Multiply both sides by that denominator, and that gives the condition that P to the 3rd plus 1 minus P to the 3rd must be less than 1. So all of these are equivalent. Again, under this condition, P must be an element of 0 to 1. So then, if we multiply that out, we get P to the 3rd plus 1 minus 3P plus 3P squared minus P to the 3rd, and that's got to be less than 1. So now we can cancel a few things. So the P to the 3rd minus P to the 3rd, and then cancel the 1s. Let's see, so we're left with, that is the same as 3P squared minus 3P less than 0, which is equivalent to 3 times P squared minus P less than 0. You can get rid of the 3. That's equivalent to P squared minus P less than 0, which is equivalent to P squared less than P. And there we get to a condition that we know is true. This is always true. when P is an element of the open interval from 0 to 1. So that guarantees that we have a valid interval there.